Hello students, welcome to NEET CET Mentor channel. Today's discussion is electric potential. We have collected a previous year questions from a NEET 2024 to 2000 year. We will be solving these from recent years, okay? Yes, have a pen and paper with you. Do solve simultaneously, and I will be giving a hint and solving the questions. Be follow me, okay? Yes, physics, I will tell you again, that is physics, visualization is important. You have to visualize the question first and understand it properly. Then you will get an idea what to find, how to get the answer, and what method is that, which concept will applicable. Just reading the question is not enough. Understand it and again visualize it. You will get that what to find, how to get the final answers, okay? If you follow this method, the solving of the questions, if you have enough knowledge, then solving a question with visualization is so far better, okay? Without any delay, let's start the session. Yes, the first question. Given below two statements, one is labeled as assertion and other is labeled as a reason. Assertion. The potential V at any axial point at a 2 meter distance from the center of dipole moment, vector P of a magnitude 4 into 10 power minus 6 coulomb meter is plus or minus 9 into 10 power 3 volt. Given 1 by 4 pi epsilon naught is equal to 9 into 10 power 9 SI units. See, with respect to dipole moment, how the potential is related, and the calculation of that they have given as the answer, that is plus or minus 9 into 10 power of 3. You know the relation, that is how the dipole is related, you know, at an axial point they are asking. So P is equal to K into P cos theta by R square. If it is so, you know, at axial points the theta, the reference point from the axial point means the theta will be going to 0 or it can be 180 degree, right? If it is so, the cos 0 is a 1. So with respect, if we take a theta as a 0, then the answer will be Kp by R square. If we take a 180 degree, means the answer will be in, because the cos 180 minus 1, so the answer will be minus Kp by R square. They have given a K value as a 9 into 10 power of 9. The dipole moment, that is 4 into 10 power minus 6 divided by R square, that is 2 meter. Just substitute it, that is, see, 9 into 10 power 9 into 4 into 10 power minus 6 divided by R square, which is 4. So what is the answer? That is a 10 power 3 27 drops of a same size are charged at a 220 volt each. They combine to form a bigger drop. Calculate the potential of the bigger drop. That is 27 drops combined to form a bigger drop. Calculate the potential of the bigger drop. They have given a charge to these 27 drops, that is 220 volt, right? They are asking the potential of the bigger drop. What is the V value? See, we know basics, that V is equal to K into Q by R again. If at all we want to find the bigger drop potential, means here K is again constant and they are not talking about the charge, so the radius is important here. Hint, the radius is a very important hint to calculate the answer. If it is so, how the radius of the smaller sphere and bigger sphere are related? See, if you come from the basics, means the volume of those 27 drops which are going to come, each drops, that is 27 drops having the same value, that is same volume, making into the bigger sphere. I think you are getting my point. Volume of those small spheres will, when combined to form a bigger drop, both value remains going to be constant, that is 4 by 3 pi r cube. See, from that topic concept there is a direct formula, that is radius of the bigger drop is equal to n to the power 1 by 3 times smaller drop. Means where n is a number of small drops combining to form a big drop. So r is equal to 27 to the power 1 by 3 times r. 27 to the power 1 by 3 means, which will be cube root of the 3, that is 3 3 is a 9, 9 3 is a 27. So capital R will be 3 times the small r. Then they are telling they told to find the potential of the bigger drop. So V is equal to K into charge. What is the charge they are telling? That is see, the smaller drop is now you compare those with the smaller drop and bigger drop. Smaller drop, that is given K into small q by r. If you put for the bigger drop, that is K into, here potential of the bigger drop is equal to K into, what is the charge here? That is, if you the charge of the here volume is going to be constant, so from that relation we got a radius that is 3 times the r, small r. Again, if you take a charge, the charge from those 27 spheres will remains the same for bigger sphere, that is 27 times the charge. So in terms of this q, you can write as a 27 capital Q or small q, that is 27 times that is, and capital R as a 3 times r. From this, V of the bigger is equal to K, that is 9 into 10 power of 9 into 27q divided by, that is 3r, that is 3 times the r. Here q, r and this k value, keep it as a constant, and this 27, which is V is equal to K into Q by R, which is a hint. You go to that formula, and which is not given, you have to find that and you have to put in the final equation. That is how this entire chapter is dependent. Okay. Yes. Moving on to the next question. The variation of electrostatic potential with a radial distance r from the center of the positively charged metallic thin shell of a radius r is given by, they have given variation of the potential in the sphere with the graph. You know, potential of any this closed surface will be remains constant throughout the sphere. V at this point V1 and V2, which is at a surface, and V3, which is inside concentric imaginary line. If you consider V4 at any point, all these V1, V2, V3, V4 will have a constant potential value. So until from origin to the surface, we can tell that the graph going to be constant, so which will be constant towards the surface. After that, how this relation is dependent. You know, V is inversely proportional to 1 by r from the equation V is equal to K into Q by r. If it is so, as the radius from the surface to away increases, means the potential will decreases as the V is inversely proportional to r. So we can say that till surface it is constant, after that it is going on decreases. So option B is the correct answer. If it is the same question is asking for the electric field, means if they are asking for electric field, means at center electric field is going to be 0 at the surface, which will be having a maximum. After that, which is again inversely proportional to r square, so value goes on decreases. That means at the center it is 0, so the graph starts from the origin till maximum value. After away from the surface, as radius increases, the electric field goes on decreases. So for electric field, this will be the answer. So we found for both electric field and potential how it vary with the radius. For option C, which is correct for the electric field, and option B is a potential. Here we have they ask for potential, so the correct answer is B option. Moving on to the next question. In a certain region of a space with a volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of electric field in this region. They have given volume here. They have given a potential which is constant throughout their telling. Again, these words are going to be a very big hint for this type of question. Potential is there are terms like firstly equipotential surface, they will use equipotential surface, and again the potential is same throughout as in this question. These type of words making the great hint in this solving this question. The magnitude of electric field in this region they are asking. See how the potential and electric field are related. Electric field is equal to minus dV by dr, right? If it is so, they have given a potential here. What potential they have given? That is d into 5 times 5. The potential is a constant, that is given 5, and volume, that is volume they have given. You can take the radius from that. Volume is equal to, example, if it is a sphere means 4 by 3 pi r cube, r you can find that. Again, radius will be some constant, some value. See here, differentiation of the potential we have to do. Differentiation of any constant will going to give the answer that is 0, right? Differentiation of any function, any constant function will be 0. So the answer is 0. It is some logic question, If at all potential is a constant, then electric field at that point is a will be 0. So the answer will be option D. Moving on to next question. A short electric dipole has a dipole moment 16 into 10 power minus 9 coulomb meter. The electric potential due to dipole at a point at a distance 0.6 meter from the center of a dipole situated on a line making an angle 60 degree with the dipole axis is. They have given a dipole moment. They have given that is r distance from the dipole, and they are given 154 pi epsilon value. And also they are told and at that point is situated at a 60 degree angle. And finally they are asking for the potential. Potential and dipole moment are related by, that is V is equal to P cos theta divided by 4 pi epsilon naught into r square. See, it is nothing but 1 by 4 pi epsilon, that is Kp cos theta by r square. Substitute all these values. They have given a P as 6 into 10 power of 9, 16 into 10 power of 9, minus 9, sorry, 10 power of minus 9. Cos theta, that is cos 60. Cos 60 will be half, right? Divided by, 1 by 4 pi epsilon 12, that is 9 into 10 power of 9. Divided by r square. Radius they have given 0.6. 0.6 square, which will be giving 0.36. So, calculate it, that is 9 4 ja, that is 9 4 ja, here it will be 0.04, and 10 power 9 and 10 power minus 9 going to cancel, and 1 by 8 denominator, 8 2 ja 16. So which they have given 10 power 2. So the answer here will be 200 volt, right? Answer will be 200 volt. I think you got that calculation right. Here it is 0.04, right? If that is going denominator, means this 10 power minus 2 will be in numerator going to be 100, and left with the 2 here, 2 into 100 will be 200. That is how the calculation is. Next, ninth question. The diagram below shown in the region of equipotential. They have given 4 diagrams here which are of equipotential surface, and they are asking a question, that is, a positive charge is moved from A to B in each diagram. In each diagram, the positive charge is moved from A to B, and they have given options, that is, potential is maximum. Maximum work is required to move a charge Q in figure 3, and in all the figure work done is same, and minimum work is required to move Q in figure 1, maximum work is required to move Q in a figure 2. They are talking about the work done. Work done and potential, how they are related. Work done is equal to Q into delta V. That is, from point A to B they are asking, that is delta V, and then we can write it as a VA minus VB, right? If it is so, again this is from the basics. They are told equipotentials. This type of equipotential and potential throughout the sphere is same, which will going to give a hint. This difference means they are talking about V1 is equal to V2 or VA is equal to VB. This hint is they are given. If it is so, the VA minus VB value is going to be 0. So work done in an equipotential surface is always 0. If it is so, the options which are given here, option B given in this as, in all the 4 cases the work done is same. The work done is same. The same value is 0. Getting my point? That the value is same and that will be 0. So option B is correct. Equipotential surface, just that word denotes that there is no work done to move a charge, and the values of potential will be same throughout the spheres. Moving on to the next question. If a potential in volt in a region is expressed as a V x y z, V x y minus y plus 2yz, the electric field at a point, the coordinates they are given as a 1, 1, 0, that is x coordinate is 1, y coordinate is 1, z coordinate is 0. So how to find this value? They are given potential, asking for the electric field. How they are related? Electric potential is equal to, so electric field is equal to differentiation of the electric potential, right? If you do so, electric field is equal to minus dV by dr. So minus times differentiation, that is, you can take this equation like, E is equal to minus dV by dxi cap minus dV by dy j cap minus dz by dV by dz k cap. If it is so, they are given values, that is 6xy minus y plus 2yz. You can see here the mathematical case is here. You can take this reference, that is y given in 2 times. So take out a minus 6y outside, which is will be I coordinate, x coordinate, and minus of, you can write this y coordinate as a 6x minus 1, right? 6x minus 1 times j cap, and the z, that is 2y, which is k cap. In this equation, substitute that coordinates that are given 1, 1, 0. That means see minus 6 into y, which is given as a 1, 1, 1, 1, 0, right? Y as 1. Again minus 6x, that is 6 into 1 minus 1, that is which will be 5 here. 5 times j cap minus 2 into y, that is y value 1. So 2 into 1, 2. So here minus 6 here it is there. See once options all are given in terms of a minus, so take out the minus outside. If you take out the minus outside, you will be left with a 6 I cap, where minus into minus will be giving a plus, that is a 5 j cap. Again minus into minus, which will be going to a plus, which will be 2k cap. So the answer will be minus 6i plus minus times the 6i plus 5 j cap plus 2k cap. So the answer will be option B. Given electric potential, finding asking for the electric field. How they are related? Electric field is equal to minus dV by dr. Differentiate it, you will get the answers. Next, 11th question. A conducting sphere of a radius r, given a charge q, the electric potential and electric field at the center of the sphere respectively is. They told conducting sphere radius of which has a radius r. Electric potential and field at the center. Electric field at the center, I have told this in the previous question only. What is the electric field at the center of the sphere? Which will be 0, right? What is the electric potential at the center of the sphere? Electric potential will be constant value at the center and also surface, which will be k into q by radius. You can write, there is no option like in terms of k, they are given in terms of 1 by 4 pi epsilon naught. So substitute it, that is 1 by 4 pi epsilon naught into charge taken as a capital Q. Either take whatever in option the reference now, that will be substituted, and radius given as a capital R only. So for the electric potential, which will be q by 4 pi epsilon naught r, and electric field is 0. The option will be B. Next, moving on to the next question, that is the 12th question. In a region, the potential is represented by a v coordinate x, y, z. 3 9s are 27, that is 9 times, if you can take a common, that is k q by r, which is again constant, there is no substitution of that. So potential of the bigger drop is equal to 9 times the smaller drop. That is, if you they have told potential for each smaller sphere is 220 volt. So 9 into 220 volt. 9 into 220 means, which will be 1980 volt. Yes, the basics, that is, when smaller spheres making into bigger sphere, the volume of those final sphere is similar to those combining of the 27 spheres. From that relation, we can get the for the radius, and basic formula, that is bigger sphere radius is equal to n to the power 1 by 3 times the smaller sphere. And again, the charge that are combining to form a bigger sphere will also be same. So the charge of the bigger sphere you can substitute by 27q. Again k by r, which is of the smaller sphere, is getting separated, and the 3 9s are 27, so 9 times the smaller potential. So 9 into v, that is 220, which will be 1980. So the answer for the third question will be option D. Yes, moving on to the next question, that is fourth question. Two charged spherical conductors of a radii R1 and R2 are connected by a wire. Then the ratio of surface charge density of a sphere, that is sigma 1 and sigma 2, is. See, given two spheres, with the radius r1 and r2, which are connected by the wire. They are asking of the surface charge density. It is very important that students, this question that is NEET 2021 question, majority of the students have made a mistake in this. Average 90% of the students made a mistake in this question, which has considered as one of the tricky question at that time. Okay, yes, so we'll be solving that question only. See, they are giving the hint that is they are connected by a wire. I told when any two surfaces are connected by the wire, they are making into contact means there is a potential. The potential of those two spheres will be becoming equal. They try to going to equal, so v of those both spheres will be equal. That is the hint they have given. They are asking about the surface charge density. What is the symbol? That is sigma is equal to charge of the sphere by area of the sphere, that is 4 pi r square. They are asking about the ratio. You know, again 4 pi here is a constant, and about the charge they are not talking about any about the charge. They have given the radius r1 and r2. So again, once check the option, that is they are not given option in terms of any charge here. They are given in terms of r square. So this charge, you know, we have to substitute it by the radius r value. How it is possible? See, I have told that is v is equal, that is we can write as a v1 is equal to v2. If it is so, that is a q by r, that is q1 by r1 is equal to q2 by r2. If it is so, q1 by, you can write it as a q1 by q2 is equal to r1 by r2. q1 by q2 is equal to r1 by r2. We can take this q1 by q2 value, that is r1 by r2, for the our final equation, that is sigma is equal to q by 4 pi r square. We can see they are asking about the, they are asking for ratio of sigma 1 by sigma 2. Sigma 1 by sigma 2 is equal to, see here in this equation 4 pi for the both, that is sigma 1 and sigma 2, which is a constant value. So 4 pi will get cancelled. We will be left with the q1 by r1 square into q2 by, it is r2 square, r1 square r2 square. We have that is q1 by q2, we have a value. We find out now relation, that is from the reference here, q1 by q2 is equal to r2 square by r1 square. Just substitute it. That is r1 by r2 into r2 square by r1 square. Here r2, that is square will get cancelled with r2, r1 get cancelled the power. So we will be end up with the r2 by r1, r2 by r1. The main thing that students have gone in this question is they have a charge value, and charge value, that is q is here. They won't able to found this q in terms of r. So majority of them have put, that is here we have r power, no, r power square. They have take that answer, that is majority have put the answer, that is r1 square by r2 square. But the final value will be r2 by r1. The option B will be the correct answer. I think you got it. You know, majority of these questions will be substituted easily. You will get to know what to find only by, you know, if you put v is equal to k into q by r, you will get to know from what hint they have given for how we have to find. We will get to know from that one. In a region, the potential is represented by v x comma y comma z is equal to 6x minus 8xy minus 8y plus 6yz, where v is in volts and xyz are in meters. The electric force experienced by the charge of a 2 coulombs is situated at a point. This is same type of question that that you know You have solved it at 10th question, right? Same like that question only. Electric field is equal to minus dV by dr. Substitute it, and they are asking for the force. First substitute, that is E is equal to minus dV by dr. Find out E value. After that, take out a E net, that is how electric field net will comes. After that, they are asking for the force at how electric field and force are related. F is equal to Q into E net. So substitute in that, you will get a force. Calculate by yourself. I have told you. For that, answer will be option D, 4 into root 35 Newton. You only solve it, you will get some idea of calculating these vector type of questions. You know, there is a vector chapter which will be not directly asked from that chapter, but they will that basics will be applied to these type of chapters, and combining and asking questions. Okay, those type of questions you have to be careful and you have to solve perfectly. Let's move on to the next question. A, B and C are 3 points in a uniform electric field. The electric potential is, see, there is a statement that is the electric field lines are moves from decreasing the potential, that is electric field lines will be decreases as will be moving from higher potential to the lower potential. Field lines are flow from higher potential to the lower potential. If these arrows are making that these electric field lines are nearer to A and somewhat this distance from C, and again B is somewhat greater distance from the C. Electric field lines flow from higher potential to the lower potential. That means the A here, which is nearer, and B, which is somewhat far, and C is a further far. So A is nearer means it will have a decreasing potential than point B, and again decreasing potential from the point C. If it is so, the electric potential is maximum at B. Maximum at B. So the answer will be option B. Yes, moving on to the next question. That is 14th question. 4-point charge minus Q, small q, 2Q and capital 2Q are placed one at each corner of a square. The relation between capital Q, that is a positive Q, and plus small q, for which potential at the center of the square is 0. See, they are talking about the square. They have kept all those charges at corners. Take a square, one corner minus capital Q, another in small q, and there is a 2 small q, another one is a 2 into capital Q. And they have given one hint, that is potential at the center of the square is 0. They are telling at the center V value will be 0. If it is so, the relation between Q and Q they are asking, that is capital Q and minus Q. How to find this? See, if V is 0 at a center means you can get a one relation, that is sum of the potential at these points A, B, C, D, if you take corners, will be 0. Sum of the potential of all those corners will be, that is 0. Then we can write V1 plus V2 plus V3 plus V4 is equal to 0. If it is so, you can write V1 as minus KQ by R. Again plus times again they have given charge is minus, so minus times K small q by radius will be same for all those corners, right? So again 2 times K into Q by R, and again which is a positive charge, that is 2 times K into capital Q by R. If this relation is equal to 0, they have told, right? All this relation is equal to 0. If it is so, just take out the LCM there. That is 1 by R will be getting in separated 1 by r, and that is k also is common there, k and r is common, so k by r. You will be left with the charges only, that is minus q, again minus small q, plus 2q, plus 2 capital Q, which will be 0, as this will be k by r, which multiplies values going to the right side getting a 0. So we will be left with this minus q, minus capital Q, minus small q, plus 2q, plus 2 capital Q. Then here these two functions are same, so minus 1 plus 2, which will be minus 1 small q, again plus 2q, and minus q, which will be plus capital Q, which is equal to 0. So we can say that plus q is equal to minus 1q minus q. So the capital Q and minus q are related by a negative sign, right? If they are related by a negative sign, means the option will be A. The hint here in this is the center of the square, the potential is 0. Then means the summation of all those corners which making into square will be getting 0, and substitute all those values in the that summation, and try to get the final answer in terms of the charges. Then you will be getting answer as a capital Q is equal to minus times the small q. Yes, it is okay. And moving on to the next question. 4 electric charges, that is capital small positive small q. The diagram is given here, how this is arranged. Okay, are placed at a corner of the square of a side 2L. The side here given as a 2L. It's not a only L, it is a 2L. The electric potential at a point A, that is here given point A, midway between the two charges, that is plus q and plus q, is electric potential at that reference point. They are asking from all those 4 corners. How to find this type of a question? This is somewhat related to the previous question, but they told that there V is 0 at a center, but here with reference to a point they are asking. So potential again, V is equal to kq by r. We can say that here these 2 plus q and plus q, and again these 2 minus q take separately. You can say that total V total is equal to 2 times V due to positive charge and 2 times V due to negative q charge. So we can write this as, substitute the value, that is a k into 2 times the charge, that is small q, by what is the reference of the length they have given. For a first equation, that is from these two, which will be different, which will be separated by L from that A point, and in the second, that is here they have given minus charges, right? So minus sign will come, 2q by r, the distance, how much distance it is from. See this length is the distance. What is the value of that length? Means which is the root 5 times the L. You have to get how to get that. See, they have given hint, there is triangle here, 2 given here, 1, that is 1L is given there. From the Pythagoras theorem, you can say that root of 2 square plus 1 square, which will be root of 4 plus 1, which will be root 5. So the distance of that will be 2q by root of 5 times the L. From that, again substituting that, V is equal to, take a 2 common there from these 2 and L there, and we will be getting 2q by 4 pi epsilon naught L times 1 minus, see here all are getting outside, so 1 will be left, 1 minus 1 by root 5 will be left here in the denominator in this equation. Search for this equation if at all they have given answer, means yes, 1 by 4 pi epsilon naught 2q by L times 1 minus 1 by root 5 is given here. So here the option B will be correct answer. Moving on to the next question, that is 16th. The electric potential at a point P xyz is given by V is equal to minus x square y minus x z cube plus 4. The electric field E at a point is. They have given electric potential, they are telling to find the electric field. This is the same, that is differentiation by the equation E is equal to minus dV by dr. We can do this, solve this. We have discussed this type of question again from the 10th question. The same method is to be followed. You have to solve this as a classwork. Okay, do it by on your own, and the answer for that will be option A, that is E is equal to 2xy plus z cube I cap plus x square j cap plus 3x z square k cap. Do solve it by your own, then you will get some idea of calculation. Next, moving on to the next question, that is 17th. Here this 18th question, moving on to the 18th question. The electric potential at a point in a free space due to a charge q coulomb is given by q is into 10 power 11 V. The electric field at that point is. They have given electric potential in terms of a q, electric field they are asking. Again, see, basic relation, that is V is equal to kq by r, kq by r. Again, you can write that V as a 1 by 4 pi epsilon naught q by r, and asking for the electric field. Electric field is equal to E is equal to 1 by 4 pi epsilon naught q by r square. V is inversely proportional to r, but E is inversely proportional to r square. From this relation, how these two are related? That is, we can write E is equal to four pi epsilon naught V square by q, which will be 4 pi epsilon naught into q square into 10 power 22, that is 10 power 22 divided by charge q. If you cancel these two, you will be getting final answer, that is E is equal to 4 pi epsilon naught q times 10 power 22 volt per meter. Then the answer will be option A. Yes. Moving on to the next question, that is moving on to the next question, 20th question. Okay, see here, two charges, that is q1 and q2, are placed 30 centimeter apart. q1 and q2 30 centimeter apart. The charge that is a q3, which is moved along the arc of a circle of a radius 40 centimeter from C to D, which is given 40 centimeter here. And they are telling charge C is moved from that q3 is moved from C to D, right? The change in the potential energy of the system is given. Change in the potential energy is where k is okay. They are asking what is the change in the potential. This is another type of a question where how the potential energy are calculated. Potential energy can be calculated for the two charges. So we can just take a reference of here with respect to C, UC. If you take, you can write it as a K into, first take for this, that is A and C. So find the potential energy of these two systems, and again next find the potential energy of the A and B. After that, they are asking potential difference, that is Vd minus V3. From this point to this point, that charge is coming. So
you will be substitute minus that is subtracting ud minus uc. You will get a one value which will be again substituted by some those values. You will be getting answer. I will be solving that clearly. Okay, vc at that point, vc is equal to k into q1 q3. How much it is related? Q1 q3 divided by r means how much? 40 plus q2 q3. How they are related? That is q2 q3 by 30 centimeter and by q2 q3 which is a 50 centimeter, right? No, it is right, correct. No, here they have given hint. Here b to d distance how much they don't have given. They want given. We have to find that is 10 centimeter, right? We are finding for the vc. How q2 q3 difference? That means which is 0.5, right? Which will be 0.5. That is 50. So a q3 at a d, the potential g is, find the potential at a d. ud is equal to k into q1 q3 by 0.4 plus q2 q3 by 0.1. After that, change in potential energy that is asking, that is change ud minus uc, right? Change means ud minus uc. So into k times q2 q3 by 0.1 into minus q2 q3 by 0.5. So after substitution, you will get this as a q3 by 4 pi epsilon naught times k. And if you again consider this, you will be lastly getting k is equal to q2 times 10 minus 2, which is equal to 8 times q2. So final answer will be 8 times the q2. Actually, this type of question will not asking in the these upcoming years, because this question is from the AIPMT 2005. Then NTA has came from the 2019, where the syllabus and asking of a question is one are different from the previous AIPMT years. Okay, don't worry about those type of difficult questions and also mathematical equation questions. You will not getting those questions in these years. Just have a tricks and logic type of questions will be asking. Some basic mathematics will be there. That's it. Again, we will be moving on to the 21st question. In this 21st question, as per this diagram, a point charge plus q is placed at origin O. A work done in taking a plus q kept at a origin point, right? Work done in taking another point charge, that is minus q, from a point A. They are telling minus q charge from point A to another point, that is B, along the straight path AB is. See, this type of question we can expect. Here, there the mathematical equation was lengthy, but in this question you have a concept, that is work done and potential related by work done is equal to VA minus VEB. Again, this is a basic calculation, and you know here VA and VB, which are of equal distance. Work done is equal to q times VA minus VB. Here VA and VB, which are located at same point, that is, if you take this as y axis A, you can take this as x axis A. So VA minus VB, again basics which are same, means the VA minus will be 0. So entire work done to move a charge in the equidistance will be 0. That is, there is no need of work to move a charge from a point A to point B. So the answer will be 0. Straightforward question is that. Just to understand the question, visualize it, you will be getting that final answer. Okay, Moving on to the next question, that is 22. A bullet of a mass 2 gram is having a charge of a 2 microcoulomb. Throughout, the potential difference must be accelerated, starting from the rest to acquire a speed of 10 meters per second is. What they are asking in this question? They are asking about the what is the potential, final potential. This is a favorite question. These type of questions are full marks questions, where they have linked the mechanical concept and the electrical concept. How the work, kinetic energy from the mechanic formula, and again the work done in this electrostatics. The kinetic energy from the mechanics we can write as a half mv square, and again which is has a same in electrostatics as a work done is equal to q into v. If you know this, you will get an equation that is here v is a velocity where this v is a potential. So if they are asking for the potential, right, take a v, separate here potential. I will put like this. V is equal to root of v is equal to mv square by 2q, not a root, mv square by 2q. Potential v is equal to mv square by 2q. Remember this formula. This formula is exactly applicable if they are asking for the velocity relation with respect to electrostatics. Remember this is going to be directly helpful in solving this type of questions. If you substitute this question, to this means you will be getting this final answer. See, mass they have given 2, and velocity they have given 10 meter per second, that is 100, divided by 2 into charge they have given 2 microcoulomb, that is 2 into 10 power micro means 10 power minus 6. So 2 and 2 get cancelled, and 1 by 2 into, and this 10 power minus 6 goes 10 power plus 6, and 10 power, which will be 10 power 8, right? Here they are told 2 gram. So okay, 2 gram mass is a 2 gram here. This type of the SI unit of weight is mass is given by kg. If they are given in terms of a gram, means you have to substitute it as a 10 power minus 3. Sometimes these type of SI units will make the answer different, because both in options both will be given, then you will be going wrong. So be careful on those units and substitute it. You will have a numerator as a 10 power minus 3 and 10 power plus 3, which will be again 10 power plus 3, and this 100 will be there here, 100 is here. So which will be half into 10 power of 5. Half into 10 power of 5 means we can write it as a 10 power of 5 by 2, which will be 5 0 0 and again another 0. That is, we can write, just check the option how they have given. They have given in terms of 50 kilowatt. Okay, 50 kilowatt is also given there, which is option B. So we can say that it is a 50 into 10 power of 3, then answer will be 2. Option will be second option. This is how the mechanics and electrostatics will be asking. Remember that formula, that is potential is equal to mv square by 2q. Next, moving on to the next question, that is 23rd. Some charge is being given to a conductor, then its potential is. Some charge is given to the conductor, then its potential is. See, this is from the basics, that is from the concept. Whatever it is, if they are giving a charge on anything in the entire this surface, whatever the charge you give, which will be such that the potential will gonna same from center to the surface. So that is the basic. They are only playing a game with the students by giving by the concept of equipotential surface. So the V will be remains constant throughout the surface. So the answer will be same throughout the conductor. So option C is the correct answer. Okay. Moving on to the next question, that is 24th. Identical charges minus q are placed at each corner of a cube of a side B. Then electrostatic potential energy of a charge plus q placed at the center of the cube is. Okay. Electrostatic potential energy they are asking. So, how we have solved one question like this question, just electric potential concept, potential energy concept. They are telling the cube, right? If you say this is a cube, minus q is placed in all those corners. Minus q is with the side is B, right? Okay. A positive charge, that is plus q, which is placed at the center of a cube. Okay. They are asking of the potential. See, this type of questions will be commonly asking in the NEET. Okay. See, in this electrical potential energy they are asking, right? U is equal to, K into Q1 Q2 by R square, basic formula. You substitute this, that is K into overall how many charges are kept there, that is 8 charges are kept, because the 8 corners will be there for the cube. So they are not given 8 charges are kept. You come to know that is cube having 8 corners, so 8 charges you have to consider and substitute it. So 8 into K times charge, that is with respect to all those corners are minus q, so we have taken 8. If at all those charges are not identical, we are not able to take that 8. We have to substitute all those charges and we have to calculate it, because they are all minus q. With respect to center, that is a given positive q, we have to find this q1. If you consider the minus q at corners, means which will be minus times q again into which is center, which is having a positive q value. So multiply that and divided by r square. What is that in cube from center to the corner? From in this cube, the diagonal of the cube having this will be B and side will be B. The entire diagonal will be having a root 3b. This diagonal of the square, diagonal of the square will be root 3 times the side. Diagonal of the triangle will be, if you go, from this, say this is, they are not talking about this triangle, they are talking about the cube, right? We will require a square. This will be root 3b, and this charge is kept at the center of the cube, not of the square, center of the cube, which we can get as a root 3 by 2 times the b. If you find that root 3 by 2 times b means, you can directly substitute it, that is r is given as a root 3 by 2 times side. Again the value is given in terms of 1 by 4 pi epsilon naught. Substitute k as like that, so you will be getting finally as a, that is q into q square. So this 2 will be going in the numerator, and for 1 by 4 pi epsilon naught here, 1 by 4 pi epsilon naught times 8 into q square divided by root 3, that 2 will go into numerator, 2 2 ja 4, 2 4 ja 8, which will be 4 by root 3, that is minus n, because the q1 was minus q charge, right? Minus times 4 by root 3 q square by pi epsilon naught times b. This is what final answer we will be going to get. For this option, the correct option will be option C, that is minus 4 q square by root 3 pi epsilon naught b. I think you got potential energy means compare with the 2, that is u is equal to k times the q square by q square by r. If it is so, the charges are same at a corner, so we can directly multiply that by 8 times and finding that value is a easy way. If those are not identical, you have to do it for each and every, that is 8 time calculation you would have done, and you will be substituting that. Okay, let's moving on to the next question, 25th. In bringing an electron towards the another electron, electrostatic potential energy of the system is, see, electron, which is having a negative sign with it, moving those two electrons with each other, potential energy of the system they are asking. When when those charges are coming nearer, potential energy is how the potential energy is related. Just have a formula, U is equal to K cube Q square by R. Here potential energy is inversely proportional to R, right? If the distance of between those two charges goes on increases, means potential energy of that will be going decreasing. If the distance between those two charges is going to decrease, means potential energy of that system going to increase. Here they are talking about the decreasing the distance between them, you can, so potential energy going to increase. If these two charges going away from each other, means the distance between them increases and potential energy would have decreased. So just have basics, that is potential energy is inversely proportional to the distance between two charges. So if distance between them decreases, potential going to increase. And again, if you have basics, that is negative, that is unlike like charges, the minus q, like charges repel. Why those like charges repel? Because they will have a high energy here. They wanted to be in the stable condition. Stable means which will be in the least energy system, so they will go away, they will move away, not each other. Okay, this is what basics. Again, if you want from the equation, means potential energy inversely proportional to distance between them. Okay, moving on to the next question, that is 26th question. An electron of a mass m, charge q, is accelerated from a rest through a potential difference v volt in vacuum. The final speed will be, again, potential, we have a value that v is equal to that is ev is equal to half mv square. We had that from the dual nature chapter. If it is so, it is from the law of conservation of energy, and means this mechanic part is equal to the electrostatics part of a charge into potential. So if you do calculation in this, means they are asking final speed, right? Half mv square. Take equation for a v square, that is v square is equal to 2 times ev divided by mass. If it is so, this is potential, right? If it is so, v is equal to root times the 2e potential divided by m. Root 2e capital V by m will be the answer. So option C is the answer. See, if you solve this type of question, means like these formulas, that is before I told one formula for the potential, in if they are given in terms of mechanics, and means that is v is equal to mv square by 2q. Again, like this type of question, that is 26th one, remember this formula, that is speed v is related by root 2e v by m. Both are same, that equation only. If you that is for potential, remember one, that is v is equal to mv square by 2q. If they are asking velocity, means just have a cross multiplication, just have a substitution, that is for the v, will be getting this answer. Both are same type of question, asking for the different parameter, that's it. Okay, moving on to the next question, that is 27th. There is an electric field E in x direction. If the work done on moving a charge 0.2 coulomb through a distance 2 meter along the line making an angle 60 degree with the x-axis is a 4 joule, then what is the value of an electric field? Right? how this work done and electric field are related. You know, work done is equal to Fs in from the mechanics. Again, if you know work done is equal to Fs cos theta, right? Because they are given in terms of the angle, we can take this as a calculation. If it is so, if you they are given electric field, how this force and electric field are connected? F is equal to QE, you know this. So you can write this as a work done is equal to QES times a cos theta. Again cos 60 is given. What is that? Just take this, they are asking for electric field, right? Take electric field in the left side and take this work to the right side. That is denominator. We will be getting an equation that is electric field E is equal to Qs cos theta. Sorry, this electric field here we will be getting, that is W by Qs cos theta. Qs cos theta, which is for electric field. Again, I am telling, remember this formula also. That is electric field and work done is related by E is equal to W by Qs cos theta. In terms of angle they have given means. Remember this, which will be helpful. So work done they have given, that is 4 joule, and the charge they have given value, that is 0.2 charge coulomb. Again distance they have given, that is 2, and cos 60 they have given, which will be half, and this 2 and this will be cancelled here. 0.2 times 4 is equal to the 20 times, right? So which will be 20 Newton per coulomb. So option will be option D. Okay, moving on to the next question, that is the 28th one. A hollow metal sphere of a radius 10 cm is charged such that potential on its surface is 80 volt. It is charged to become a 80 volt. The potential at the center is, I think you know again basics. They are again and again asking this equipotential surface concept, such that we have solved at least 5 to 6 questions here. The surface is 80 volt means whatever it is, center is also remains the same. So from this graph we know P and R, the constant throughout the surface from origin. Okay, so if it is there 80 means here also it will be 80. At midpoint of the sphere is also it is 80, and from away from the surface it goes on decreases. They are asking for the center, so it will be same value of a surface, that is option B, 80 volt, right? Yes, moving on to the next question, that is the 29th question. Two concentric spheres of a radius r and small r have a similar charges with a equal surface charge density, that is sigma. They are telling equal surface charge density. Sigma of the those two values is same. Then what is the electric potential at their common center? Electric potential at the common center they are asking. See, consider this concentric sphere here, like this one, and another one is. Okay, this have a radius capital R, bigger sphere, smaller is the radius of the smaller sphere. Potential at the common center they are asking. We at the center they are asking. How to find the two potential of the two concentric sphere means V is equal to, you know, we have to add that is V is equal to K into potential, and the charge at that point is a capital Q. Okay, just consider this as a capital Q and radius is a capital R, which is for the bigger radius, and again which is added by K into charge that they have given as a 4Q divided by R. If it is so, after a calculation we will be getting this answer as a sigma by epsilon naught R plus R. This have some mathematical equation. This type of mathematical calculation will not be asking in these years. The option is for option for this question will be option C. Do solve this. Actually this type of difficult questions will not be asking. They will be asking with some concepts, they will be asking for the logics, they will be asking some basics mathematical tools, not at all going to the those deep substituting values like those all. Okay, this is what our today's session goes for the electric potential. We have discussed from 2000 from year 1992 to 2024 the fix from this electric potential. We can expect 1 to 2 questions. Previous recent years they have asked 2 questions from this chapter, so we can expect 2 questions which are usually basically from the formula V is equal to 1 by 4 pi epsilon naught Q by R. If you leave this, second question will be from the the mechanics and electrostatics related, that is potential V is equal to 2q square by potential V is equal to mv square by 2q. These two formula will be repeated again. Basics, that is equipotential surface concepts, will be having that, and how those graphs are related, that is again important question. And work done and potential, how they are related. Work done is equal to Q into V. How the force and charge are related, that is F is equal to Q into E. These are the basics. If you know this, you can do solve all those questions. There is nothing difficult here. I will be teaching like this entire your sessions. Okay, this is how electric potential we will be solving next coming with the capacitors. Okay, capacitors, how the capacitors will be means, those are all circuit based questions. I will be telling tricks and logics. There is no mathematical calculation in capacitors. The basics calculations will be there, but the concepts of solving those series and parallel capacitors, that will matter. So I will tell some logics, just do apply it. The capacitors will be easy. From that second chapter, that is electropotential and capacitors, from combining those two, there is a chance of getting a 3 questions, minimum 3 questions. If at all, there is a chance of 4 questions also. So electrostatics second chapter is very important. Do solve, do visualize the question, not blindly read and in the situation of not be in the situation of uh, blind mind. Just visualize the question, what they are asking, what we know for the equation. Do by that and you will get that. Okay, we'll see you on capacitor chapter. Okay, bye bye.